Okay, so today to wrap up Unit 2, we're getting out of the algebra stuff and into the stuff that kind of leads into our dosage calculations for the next unit. We're looking at measurement. And we have two different types of measurement that we're going to have to deal with. We're going to have to deal with the standard measurement and metric. Standard measurement actually used to be referred to as the English standard measurement system. Only, well, somewhere around 20 to 25 years ago, England, Great Britain, switched over to the metric system, which means the United States is now officially the only industrialized country in the world that does not use the metric system. In the medical fields, it's maybe not as huge of an impact as others, but for manufacturing and stuff like that, it's had a huge expense, so that change is going to come. The medical field actually pretty much switched over well over 10 years ago. You don't see many dosages done in grams or fluid ounces or anything like that anymore. It's mostly milligrams, micrograms, and so on, milliliters, or whatever. But we are going to review both systems just a little bit. Measurement started from a need to communicate. Let's say that we're building things, and say I'm building a piece, and you're working over there, and you want to build a piece identical to it. If we're working in the same room together, I can just take the piece over to you and show it to you, or I can just say, hey, it's this big, and you can use that. But if you're working across town or somewhere else, I have to have some way to communicate that measurement to you. I could either, I suppose I could cut something and send it to you that's that length, but if there's a lot of them or if it's really long, that's tough to do as well. So we needed some way to write it down and record it, or now that we have phones and stuff to verbally communicate it, what a size was. Now I could take my pen here and say, okay, I'm going to measure across my screen. It's 1, 2, 2.5 pens across the screen. Well, I'm making a big assumption. One is that you have a pen and that your pen is the same size as this one. If your pen looks like that, a little dark, you can't really see them there. If your pen's like that, well, your measurement's going to be very different from mine because your pen's a lot longer or shorter or whatever. So what they chose was things that pretty much everybody had and were approximately the same size. For example, we're not going to do a whole lot with length, but an inch came from the distance from the tip of a man's thumb to the point of the first knuckle. That was an inch. They had units like the hand, which is the width of the hand at the base of the fingers. The foot is a pretty obvious one, and things like that. And because they were using body parts, there was limitations. The only reason they used the hand as a measurement is trying to measure the height of this wall. Using an inch, it would take too long because that's such a small unit. A foot would work well, but if you're using your foot, trying to get your foot to the top of that wall is going to be a little bit tricky. So they had to use hands. So as measurement became standardized and they started using rulers, and actually started with a block of wood that was cut to the length, and they used those. Now that they didn't have to get their foot up there to measure the wall, they could use feet to measure height, and the hands became really obsolete. But the only place I know that they use hands for measurement anymore is for livestock. Stuff like that. So anyway, let's look at some of our standard and metric units. We're actually going to look at completely standard units for now. We'll come back to metric later because the metric units all tie together. Our standard units. We'll start out with weight. We'll start out with the large ones and work our way down here. The largest unit of weight that we'll even discuss, doesn't come up a whole lot in medicine, hopefully, is a ton. The next smaller unit is a pound. It goes all the way down to the pound. Can anybody tell me how many pounds are in a ton? 2,000. Good. Now, 99.99% of the time when you hear the word ton, they're going to be talking about 2,000 pounds. But that is actually what's called a net or a short ton, which implies there is something out there called a gross or a long ton. A gross ton is 2,240 pounds. The abbreviation for pounds, by the way, is lb. Comes from the Latin word libra, which is the Latin word for pound. The reason for lb, by the way, tons and pounds were originally used for buying and selling grain. And in the bookkeeping that was done for buying and selling grain, PD was already used for paid. So they had to use LB for pounds. So anyway, what's the difference between a net and a gross ton? Well, as I said, tons were originally used for selling grain, and you can't throw a ton of grain on a scale. It kind of falls off. So they had to put it in a container. The container that held about 1 ton of grain was about 240 pounds. So think of your gross paycheck. Your gross pay is all the money you earn. If you work 40 hours a week, $12 an hour, that's $480. That's your gross pay. That's everything. But you don't get to keep that. They take out taxes and other stuff. What you actually get to keep is your net. So the net ton is the actual grain that you got once you took the container away. Like I said, you don't necessarily have to write that one down and remember it, because I'll never test you on it. But it's sometimes good to know that there is another ton out there. Sometimes you might see that, think that it's a mistake, but it's not. So anyway, smaller than a pound. What's the next smallest unit? Ounces. Very good. How many ounces are in a pound? 16 ounces in a pound. Good. And smaller than an ounce. Abbreviation for ounce, by the way, is OZ, which also comes from the Latin word for ounce, and I can't think of it right now, so you'll just have to trust me. What's that? Well, grams would be going metric. I mean, we do use that conversion between ounces and grams a lot in medicine, but there are smaller units within the standard system. Sounds a lot like grams, but it is drams. There are 16 drams in an ounce. The dram was one of the original apothecary units. They might prescribe 1/8 of a dram or 1/4 of a dram of medication for pain or whatever. Smaller than a dram, there's grains, but we're actually going to discuss grains in the metric system because for medical purposes, the grain has been absorbed into the metric system for use because it was so pardon the pun, but so ingrained into the measurement of medicine that they had to keep it. Just so you know, again, this is outside the scope of what anything I will test you on, but you hear a lot on the news, precious metals, gold, silver, stuff like that. Hear about gold hitting $2,000 an ounce. What they're talking about there are not the ounces that we are familiar with. Precious metals are measured in troy measurement. Troy measurement actually comes from the island of Troy in the Greek islands. For some reason, that was established as the precious metal trading capital of the world. One of the flaws with the standard measuring system is a pound in the United States and a pound in Europe and a pound in Asia was not necessarily the same. There was the imperial pounds, there was standard pounds. I mean, they weren't standardized from one place to the next. So the Troy, island of Troy had their own pounds and ounces that were different than everybody else's, but they were adopted for precious metals. 1 troy pound is only, and again, you don't have to memorize this because I'll never test you on it, is only about 0.83 standard pounds. However, 1 troy pound, only instead of 16, it only contains 12 troy ounces. So a troy pound is considerably smaller than a regular pound, but a troy ounce is actually a little bit larger than a standard ounce. So when you hear that talk on the radio about gold and silver, gold hitting $2,000 an ounce or silver hitting $100 an ounce or whatever, that's what they're talking about. Slightly different units than what you're used to. Let's look at standard volumes. In our standard volumes, we're going to go ahead and we're going to start out with grams. Or not grams, gallons. I'm switching systems out. A gallon was actually a pretty standard container that they had, about 1 gallon of water or 1 gallon of fluid. Actually, it came from, there was a certain hat that was always about 1 gallon as well. That's where they come up with the 5-gallon hats and stuff like that. They were bigger hats. But anyway, smaller than a gallon. 1 gallon gets split up into quarts. What's that? How many quarts in a gallon? 4. There we go. The word quart actually comes from quarter gallon. So that's one way to help you remember there's 4. Because that is the one that's a little bit different, is the 4 quarts in a gallon. Smaller than a quart, there is a pint. How many pints are in a quart? 2 pints in a quart, yes. Smaller than a pint, we have a cup. Now, a cup actually is sometimes referred to as a half pint, so it implies that there are 2 cups in a pint. Smaller than a cup, we have fluid ounces. 1 cup is 8 fluid ounces. As we go smaller from there, 1 fluid ounce is 2 tablespoons. Smaller than a tablespoon, teaspoon. Very good. Anybody know how many teaspoons? This one's a little bit different as well. There are 3, yes. A little bit of a side note on these as well. Tablespoons, abbreviation, can be T, capital T, SP, can be capital T, BSP, small t, BSP, or just a capital T. Any of those abbreviations means tablespoons. Teaspoons can be small TSP or just small t. Now you can see the possible confusion there between those 2 abbreviations and those 2. So just a word of warning to be careful there. If you're making cookies and it calls for 3 teaspoons of salt and you misread it and put in 3 tablespoons, trust me, it tastes a little bit different when you're done. I haven't thrown away too many cookies in my life, and I can't even eat them. So anyway, smaller than teaspoons. These next couple I'm going to name off you don't have to write down because I'm just throwing them out there to show you that they exist. There is smaller than a teaspoon. We have a dash. There are 2 dashes in a teaspoon. 1 dash contains 3 pinches, and 1 pinch contains 2 smidgens. You've probably heard those words used. They actually are. You can actually. I have a good friend of mine who's a caterer who actually has the little measuring spoons for those. Where a lot of these come, the cup, of course, is just from your cupped hand. I've checked her on it. She doesn't use a cup for anything. She just pours the flour or sugar right in her hand. And I've checked her, made her dump it into a cup, and she is dead on pretty much every time. But the cupped hand, how much powdered would fit in your cupped hand is 1 cup. Now, when we've gone to the standardized little plastic cups for measuring, we were able now to use it for liquid measurement as well. So what we're looking at here for volume is actually a combination between the powdered and the liquid measurements put together. Quarts and pints were originally liquid measurements. Cups were not. Cups were dry measure, and teaspoons and tablespoons were kind of dry measure. But the dash came out of, they had spice shakers. So literally, and they're not talking like your salt shaker now. They had big ones with big holes in them with just 1 single dash of the shaker. The pinch is pretty obvious. Reach in and pinch whatever you can. The smidgen, I think, is a little bit disgusting. It was just you stuck your finger into it, and whatever stuck to your finger, you flicked it into the batter. So don't want to know what made it stick to your finger because that's where I kind of lose interest. But anyway, it's always fun to throw those out there because most people don't realize that those are truly measurements. Now we also have some smaller units that come into play in medicine. One is a teaspoon is 60 drops. Now I have to be very careful with this. It's 60 drops of water. Now, in a little bit, when we talk about the conversion between standard and metric units, we'll look at a teaspoon, what is it, 5 teaspoon or 5 milliliters in a teaspoon. That would imply 12 drops in a milliliter, but that's not always true. 12 drops of water in a milliliter, but you can have fluids that are thinner or thicker where it takes more or less drops than that to make a milliliter a teaspoon. And really for right now, I think that's all we're going to be concerned about for the smaller ones. I suppose I could do the 1 dram, or fluid dram, I should say. It's divided into 60 minims. Oops, I can spell. A minim is a unit that is almost never used anymore. Pretty easy to remember. Minim and a minute sound a lot alike. There's 60 of them. You just have to remember that it is from the fluid dram. A fluid dram, if you wanted to compare it to a teaspoon, remember a dram is a 1/16 of an ounce. A teaspoon is about a 1/6 of an ounce, so a fluid dram is a little bit smaller than a teaspoon. I haven't even really listed a fluid dram yet because they're not used that much anymore. But 1 fluid ounce, of course, is the 16 fluid drams. Okay, other than that, like I said, we'll talk about grains in a little bit when we hit the metric units. Any questions on those units so far? So if I want to convert between units, there's a very organized way of doing it. And it's called dimensional analysis, and we're going to look at it even more in a little bit. Your textbook kind of takes it to a ridiculous level. But anyway, to convert units, let's say I have 42 ounces. And I want to know in decimal pounds, what does that come out to be? Well, many of us, we've worked with ounces and pounds enough. We know that the conversion is 16, and we know we're going to multiply or divide by 16. The question is, do we multiply or divide? Well, the units going from ounces to pounds, the units are getting larger. The amount of material we have is not going to change. So if it's going to be a larger unit, the number must get smaller, right? To make it smaller, we would be dividing by 16. So 42 divided by 16 should be 2 5/8 pounds, or 2.625 pounds. But what if you didn't understand what I just did there? If you weren't able to follow that logic of the units getting larger, number getting smaller, or you always get confused and you make a lot of mistakes doing it. That's where the dimensional analysis really kicks in. What we did here was a form of dimensional analysis, analyzing the unit getting larger, number gets smaller, and all that. But there's a more formal way of doing it. I can take my 42 ounces, and I'm going to make it into a fraction by putting it over 1. And at this point, a lot of you are probably thinking, how does making it into a fraction ever make anything easier? Well, in this case, it does. Bear with me. We are going to multiply this fraction by a conversion factor. And the conversion factor is actually going to do the conversion for us. We want to end up over here with pounds. To do that, I have to get rid of the ounces. So I'm going to put ounces on the bottom of my conversion factor. The reason I'm doing that is now when I multiply fractions, I can cross-cancel. The ounces, the unit of ounces, will actually cross-cancel and disappear. Since I want it to become pounds, I'm going to put pounds on top. And now what's my relationship between pounds and ounces? Well, I look it up. Yeah, 1 pound is 16 ounces. So I label them. Let's take a look at this fraction right here, this conversion factor. It has a formal name called a unity fraction. A lot of people look at the word unity and they think it means together or combined. Unity actually means 1. This fraction right here, 1 pound over 16 ounces, is really the number 1. It has a value of 1. It doesn't look like it because it's 1 over 16, but pounds and ounces are 1 pound and 16 ounces are the same thing. Its true value is 1. It just appears different. So when we multiply anything by 1, it does not change its value, but it can change its appearance. Just like when we had fractions, if we had 3/4 and we multiplied it by 5 over 5, we were multiplying by 1, but it changed the appearance. 3 times 5 is 15, 4 times 5 is 20. It looks different, but it has exactly the same value. That's exactly what we're doing down here. So the ounces cancel out. We have 42 times 1 pound is 42 pounds. I'm going to write that over here. 1 times 16 is 16. So now we look at this, and we have to reduce that fraction by dividing it out. 42 divided by 16 gives us that 2.625. So let's do a couple more examples of that. I said pounds and ounces, you possibly have worked with those enough. You don't need to set up dimensional analysis and do the unity fraction and conversion. But let's look at some units that you maybe not as familiar with. Let's say you want to look at having 7 ounces, you want to convert into grams. Well, we're going to put the ounces in a fraction again. In my conversion factor, for right now, let's not worry about any numbers. Let's just worry about units. I always do the bottom of the conversion factor first because that usually makes more sense. What unit's going to go down there? Ounces are going to go down there because I need them to cancel out. What unit's going to go on top? Grams. My relationship between grams and ounces? Yeah, 1 ounce is 16 grams. I write them in. 1 ounce, 16 grams. So now in this one, it's 7 times 16 grams is 112 grams. 1 times 1 is 1. So that ends up being 112 grams. What do you think? Better than a sharp stick in the eye? For now. We could look at something like this. Changing 2½ cups into teaspoons. Now I did this one on purpose because nowhere at this point have I given you a direct conversion from cups to teaspoons. We don't need it. We're going to make the 2½ cups over 1, and now we're going to start our conversion factors. Well, we're getting rid of cups, so we're going to put cups on bottom. But like I said, we don't have a conversion, direct conversion from cups to teaspoons. So we just have to start moving in the right direction. We do have a conversion from cups to fluid ounces. 1 cup was 8 fluid ounces. What this does is it'll cancel out the cups, and now our units are going to be fluid ounces. But we have to keep going. So I'll put fluid ounces on bottom here. Again, we don't have a direct link from fluid ounces to teaspoons, but we can go to tablespoons. 1 fluid ounce is 2 tablespoons. So now again, we've canceled out the fluid ounces. They'll cross cancel out, and our units are now tablespoons. Now I want to get rid of tablespoons. I'm going to put tablespoons on bottom, and now I can get to teaspoons. 1 tablespoon is 3 teaspoons. Good. So now I cancel out the tablespoons. I'll be left with teaspoons, and I'm going to multiply across the top. 2½ times 8 is 20, times 2 is 40, times 3 120 teaspoons. 1 times 1 times 1 times 1 is 1. So it's 120 teaspoons. We can also use these conversions if we have more than 1 unit. For example, if I tell you that on my way into work today, I was driving 90 feet per second, That means every second my car went 90 feet. Would you believe me? Is that fast? Sounds fast to me, but is it? Well, what units are we used to seeing speed expressed in? Miles per hour. So if we can convert that into miles per hour, then you could tell whether I needed to go to jail or not, right? Don't answer that question, by the way. I'm sure as my students, you can probably think of several reasons why you'd like to see me thrown in jail. So anyway, we first have to start out with that 90 feet per second. We have to change it 90 feet over 1 second. And we want to end up with miles over hours, which means the feet at some point have to be changed to miles, and the seconds at some point have to be changed to hours. I'm going to start out with the feet. I'm going to put feet down here. They're gone. Miles will go on top. Now I realize we haven't discussed miles and feet, but one mile is 5,280 feet. Next, I need to get rid of the seconds. Seconds are going on top. Why are they going on top instead of on bottom? Yeah, I want them to cancel, and the seconds are on bottom over here, so they have to go on top here to cancel out. Now, we don't necessarily have a direct link to hours, so we're going to go from seconds to minutes. 1 minute is 60 seconds. Then we'll go minutes to hours. 1 hour is 60 minutes. So the minutes cancel out. So now we can go ahead. 90 times 1 mile is 90 miles times 60, 5,040 times another 60. I believe that's 324,000 miles that comes out to be. You guys can double check me if you'd like. On the bottom of this, we have 1 times 5,280 times 1 times 1 hour, which is 5,280 hours. So the last thing we have to do is we have to divide this out. 324,000 divided by 5,280 is what? 61.36. And that is miles per hour. So I may have been bending the rules, but I wasn't horrible. So you can see this would have been a really tough conversion. Unless you have memorized somewhere that it's 0.67 approximately miles per hour equals 1 foot per second. Which I don't expect you to have that memorized. I'm the only weirdo in the room that does. Doing this conversion would be very tough to do. But the dimensional analysis, without having to know any formulas or anything like that, it just allows you to look at the units and know, hey, if I want to get rid of feet, I got to put feet on bottom so they cross cancel out, and I have to find something I'm going to change it to put on top. And then I just make that equivalency. 1 mile equals 5,280 feet. So this fraction right here is equal to 1. So I can multiply by it. Next unit, when we get into the dosage calculations, this concept right here is going to be huge. There are 3 different processes we can use for dosage calculations. The dimensional analysis is probably the most useful and most universal process because you can use it on every problem. So anyway, now let's take a look at the metric system. In the metric system, everything just kind of seems to fit together. First of all, in the metric system, there is only, or at least originally, there was only 1 unit of measure for each item. For example, for volumes or capacities, they used liters. By the way, get used to seeing that spelled L-I-T-R-E. And that's the European spelling of liter, and it's starting to catch on in the United States. For length, they use meters. For mass, they use grams. There's gram, we'll put in. if they wanted to measure something larger or smaller than these units, they used prefixes to represent a fraction or a multiple of each of those units. For example, the prefix centi stands for 1/100th. No, I'm not going to put that in there. Should be careful. I started out with centi because that's probably the most popular one. Centimeter, centiliter, centigram, like that. At least it's the one that most people hear the most often or most familiar with. It's actually not the most used outside the United States, but we'll get to that in a second. There's the prefix deci, which means 1/10. So it's abbreviated with a D, so deciliter, decimeter, decigram. A little side note, by the way, the abbreviations here, of course, liter is L, meter is M, and gram is G. When I was growing up, we were always taught to use a capital L for liter. The reason for that was on the old typewriters, I'm dating myself a little bit, but on the old typewriters, the small L and the 1 looked identical. So if you had 2 liters, you didn't want somebody wondering, is that 21 or is it 2 liters? So we always used the capital L to make it very clear that it was an L and not a 1. Now with modern computer fonts, most fonts there's a difference between a 1 and an L, so you can tell. So it's now become acceptable to use a small L to abbreviate liters. I just don't do it because it's force of habit for me. But you will see the textbook use a small L for liters instead of a capital L. So don't let it confuse you that I always use the capital. Smaller than centi is milli. Milli means 1/1000th. So millimeter, milliliter, milligram. There are ones that are smaller than that. We're going to get to those in a minute. Going larger, we had deca. Deca stood for 10. Now, D, M, DL, DG are already used for deci. So they use DAL, DAG, DAM for deca. So DAM stood for a decameter, that is 10 meters long. Hecto means 100. So hectoliter, hectometer, hectogram is 100 liters or 100 meters or 100 grams. Kilo means 1,000. So a kilometer is 1,000 meters. Kilogram, 1,000 grams. Kiloliter is 1,000 liters. Now, many of you have probably never heard a lot of hecto and deca, meters, grams, liters, whatever. Centimeters you probably heard of a lot. Probably don't hear much about centiliters or centigrams. They created all these units, but in application it turned out that what was really used a lot was the main units, the liters, meters, and grams. Milli, the 1,000. And then kilo. Now in the United States, the centimeter caught on. Because in the United States, we were so ingrained on using an inch. The centimeter is the closest metric unit to an inch. So it caught on in the United States. Did not catch on so much in other countries. The countries that actually use the metric system as their main unit of measure, most of them use the millimeter over the centimeter. So really it's the main unit, the kilo units, and the milli units that get used the most in practice. Now in medicine, there are other things that come in. For example, the deciliter actually gets used a lot in medicine. All of your blood tests. For example, you do a blood glucose test that comes back as an 87. That is 87 milligrams of blood glucose per deciliter of blood. All your blood tests, all your blood counts are done as per deciliter. Well, also in medicine, there are smaller units that we use a lot. After milli, they stopped going every 10 and they just started jumping every 1,000. So smaller than milli, I'll put 3 lines there to indicate that there's a gap of 3. They have micro. Micro means 1/millionth. A microliter is a millionth of a liter. The technical abbreviation for micro is the Greek letter mu, like that. It looks kind of like an M with a funny tail, or a P without the top closed, or however you want to look at it. In medicine, however, the medical fields are one of the first fields to use computers trying to keyboard things in. There's no key on the keyboard for the Greek letter mu. So in the medical field, they adopted the abbreviation of MCM for micrometer, MCG for microgram, MCL for microliter. Units that we're not going to use much, but smaller than micro, is nano. A nanometer is a billionth of a meter. You hear about nanotechnology all the time right now. That's all nanotechnology is stuff that's really, really small, on the order of a billionth of a meter. I mean, picture, well, a millimeter is about that long. That's a millimeter. If you take a millimeter and chop it into a million pieces, that's a nanometer. A nanometer is actually just slightly smaller than an atom. Most atoms are between 8 and 15 nanometers in size. So you're literally looking at things the size of an atom. We don't usually have to give medications quite that small, so we're not going to talk a lot about nanometers in here, but just so you understand that they're out there. Bigger than kilo, we have some. We have mega. Mega means a million. Well, a mega gram would be 1,000,000 grams, or 1,000 kilograms. 1 megagram, by the way, they use the capital letter M for mega because they use the small letter M for milli. A megagram, being 1,000 kilograms or 1,000,000 grams, is defined to be 1 metric ton. Now again, in medicine, hopefully you don't run into that a whole lot, but it's out there. In trade, it gets used a lot. The metric ton is very comparable to a standard measurement ton. So how do we do conversions in this metric system? It's really quite simple. Let's say I have 420 milliliters, and I want to convert it into just liters. Well, looking at my chart here, I'm going from milliliters to liters. So I start at milliliters, which is right here. To get 2 liters here, I have to go 1, 2, 3 spots to the left on my measurement chart. To make my conversion, I come to my number here, the decimal point's at the end, and I have to move 1, 2, 3 spots to the left on my number. That becomes 0.42. What do you think? Not so bad? So if we have 0.28 kilograms, I need to convert to grams. I'm going again from kilograms to grams, which means I'm going 1, 2, 3 spots to the right on the chart. So my decimal point has to go 1, 2, I got to add a 0, 3 spots to the right. So 280 grams. As we continue with those, let's just do a couple. We might have $5,200 millimeters going into centimeters. From milli to centi is 1 spot to the left on the chart. So my decimal point goes 1 spot to the left, 520. Pretty simple, right? Well, I already showed you that example of miles per hour and doing that conversion with standard units. In metric units, what if I'm trying to do that? What if I have something like 520 milliliters per hour? How do I make that conversion from milliliters per hour to, I don't know, let's say we want to convert it into liters per hour. I got to drop the R for medical purposes. H is the abbreviation for hour. Oh, this is 520 milliliters over 1 hour. Since the hour isn't going to change, I don't have to do anything with that. Milliliters are going to change to liters. To get from milliliters to liters on my chart, how far do I have to move? Milliliters to liters, 3 spots to the left. 1, 2, 3. So I come here, I go 1, 2, 3. That is 0.52 liters. That's 0.52 liters per hour. What if I wanted to change the time as well? Let's say I have 2.3 liters per hour, and I want to convert that into milliliters per minute. Well, I make this 2.3 liters over 1 hour. To convert liters to milliliters, I am going how far? 3 to the left, or 3 to the right. So I have to add 2 zeros. That is 2,300 milliliters. Hours to minutes. Well, I just know 1 hour is how many minutes? 60. So I can just put that in. So now to finish this off, I have to divide 2,300 divided by 60. Oops. So we get 38.33 milliliters per minute. I'm thinking that sound means it might be a good time for us to take a break. So let's take a quick break. We'll see if they finish up. Otherwise, I'll go talk to them.